Okay, so this is going to be the start of this section on matrices. So in 11.2, we're going to discuss the kind of the intro to matrices. So this one won't be a really deep section. 11.3, 11.4 are a little bit more difficult. But you'll see matrices are actually your friend. They're really good to work with. They make everything so much easier. So a matrix is just a rectangular array of numbers, and we line them up in this way. So we have column 1, right? Column 2, column 3, column 4, so on, and then column n. So we name our matrices by their dimensions normally. So the dimensions of a matrix. When we say that, we mean like, how many rows by how many columns, okay? Dimensions of a matrix, in this case, m by n, okay? So the number of rows by the number of columns. That's how you normally name a matrix. So you look at a matrix and you can say, oh, that's a 5 by 7, or that's a 2 by 3. And you're telling somebody that has this many rows and this many columns, okay? So we have basically two matrices we're going to work with, where we have a coefficient matrix and we have an augmented matrix. This is normally the one you use when you're solving, and this is normally something you use when you're just doing addition or subtraction, or you are using determinants or something along those lines. And it really depends from case to case. Now, I wrote this one down because this is special. This is a 2 by 2 matrix, right? It has 2 rows and it has 2 columns. So this would be a 2 by 2, right? So what that means is it's considered a square matrix. And if you think about it, it's kind of like it's making a square, right? This one is more rectangular, right? Because it has more rows than columns, or more columns than rows. So whenever you have the same number of rows and the same number of columns, you have something called a square matrix. Those are really good for us in certain situations where we can only work with certain problems if they are square matrices. So we'll get to that, and I think that's more in 11.3 and 11.4. But just so you notice, like here, something else, this vertical line here is basically the equal sign. So an augmented matrix is basically taking a system of equations and it's trimming out all the fat. It's just taking the coefficients and putting them in the columns that match the variables. So this would be the X column, this is the Y column, and this is the equal sign column, or this is what it equals, right? So when you write that little vertical line, that is called your augmented portion, or that's the vertical line that separates the variables from the equal sign. So whenever you see that, you know that this problem is equal to something, okay? So writing a system of linear equations as a matrix, all you do is you take each coefficient and you write them in matrix form. So I wrote it over here. Here's 3 x's, negative 1 y's, negative 1 z's equals 7. Here's 2 x's with 0 y's, 2 z's, and 8 equals to 8. 0 x's, 1 y, 1 z equals 0. Oops, what did I just erase? Okay. So that's all you do to rewrite a matrix. So it's pretty straightforward. And this is a very common dimensions for our class, a 3 by 4 matrix, basically meaning you have a system of equations with 3 variables and you have 3 equations, okay? So it's very common to use that style of, or that size of a matrix, okay? Now, something we have to talk about is row operations. So these are what make things become row equivalent. Now, row equivalent is not the same as equals. It just means that they are row equivalent, meaning that you did row operations to recreate a new matrix. So this is what you're allowed to do to matrices. You're allowed to interchange any 2 rows. You're allowed to replace a row with a non-zero multiple of that row. So like, let's say I wanted to rewrite row 1, but twice as big. I would say 2 times row 1 and I'd get this new row. Totally legal, totally fine. It does do something to determinants, but we'll talk about that later. And that's why they're not actually equal, but they are row equivalent. Then you're also allowed to replace a row by the sum of that row you're replacing and a multiple of another row. So you can take the row you want to replace and add it to another row that you multiply by. And then you get a new row, and that new row is your replacement row, okay? So we can use these row operations to help us solve systems of equations by putting a matrix in a few special forms, okay? So one of the forms, I prefer reduced row echelon form, but we got to start somewhere. So we're going to put this in row echelon form, okay? So a lot of times this will be referred to as REF. There's another form called RREF, which is reduced row echelon form. This one's actually even faster, and I'll show you how to do it on the calculator. But I just want to start off with this first. It's a little bit quicker by hand. On the calculator, nobody cares because it's just as fast either way, whether you do REF or RREF. But by hand, REF is a little bit nicer. Okay, so here's what we're going to do. To be in reduced to be in row echelon form, the entry in row 1, column 1. So the very first value has to be a 1. Okay. So when you're thinking of a matrix, you have to have a 1 right there, okay? And then only zeros appear below it. So there'll be a 1 here, and then everything else is zeros, okay? Then the first non-entry, these are oftentimes called leading ones. The first non-zero entry in each row after the first row is a 1, okay? Only zeros appear below those ones, and the 1 appears to the right of the first non-zero entry. So it's kind of like it builds a staircase. You can have a 1 in the first row, first column, and then in the next column, you can have a 1, and then in the next column, you can have a 1, and then the next column, you can have a 1, and it kind of goes in a staircase, okay? And then finally, any row that contains all zeros to the left of the vertical line, this line right here, that left of the vertical line, appear at the bottom. So if you end up with something that's like 0, 0, 0, 0, you put that at the bottom of your matrix, okay? So this all sounds well and good. What I'd like to do is I'd like to try to show you guys how to solve this by hand, and then we'll solve it on our calculator. When you're doing the homework, you just need to practice a few by hand. The rest of them you can do on your calculator. On the exam, I will type specifically the ones I want you to do by hand, and if I don't say, then that means I'm okay with you doing it on your calculator. Just because a lot of these are very time consuming. So what we're going to do is we're going to rewrite this as a matrix. It says solve the following system by putting it in row echelon form, or putting it in matrix form and then using REF, reduced or row echelon form, to find the solutions. So first things first, I have to write my matrix. Okay, so 6, 1, 13, 2, 2, 0, 1, 1, 1, 3, 4, -1. So I wrote my matrix. Now I want to put it in row echelon form. And by the way, this is what I consider row 1, this is what I consider row 2, and this is what I consider row 3. Okay? So what I'm going to do is I am going to make sure that the first row, first column has a 1 in it. So I could do that a bunch of ways. I could divide row 1 by 2, or I'm sorry, multiply by 1/2. Notice in row operations up here, it doesn't say anything about division. That's because any division is really just multiplication by a fraction, okay? So yeah, you don't really divide, you're multiplying by a fraction, but you and I both know you're technically dividing. Division in matrices is kind of weird, so they try to stay away from that. So the thing is, I'm going to put, let's see here. What's the first? So I'm going to interchange. Let me put an arrow. So what I'd like you guys to do, if you do these by hand on the exam, and I ask specifically on that question to do it by hand, you have to tell me what you did. So I'm going to put row 1 and swap it with row 2. So this will become 1, 1, 1, vertical line, 1, and this will become 2, 2, 0, 6, and this will become 3, 4, -1, 13. Okay. Now I have a 1 in my first location, but row echelon form says that I have to have zeros below it. So this needs to become a 0 and that needs to become a 0. Okay. So what I'm going to do now is I'm going to do some more row operations. okay? The first row I'm not going to mess with, right? Because it has my 1 in the first spot. It's basically adjusted right now how I want. It has a 1 in the first column, first row, okay? However, I need that 2 to become a 0. So what could I multiply row 1 by that could wipe out a positive 2? So what if I did 2 times row 1 plus row 2 equals a new row 2, right? So that's going to be what we're going to do here. So I'm literally going to say 2 times row 1. And so remember, that's 2 times all of these. And then I'm going to plus it to row 2. Okay. Remember, the row that you're multiplying by and adding to another row, the row that's being multiplied can never be the row you're changing at the same time. So because I'm multiplying row 1 by a number and then adding it to row 2 is the row that must change. So if I do that and I add, and I need to multiply by -2. Sorry about that. It has to be a -2, right? Because I need it to cancel. So -2 times row 1 would be -2 plus 2 is 0. -2 plus 2 is 0. -2 plus 0 is -2. And -2 plus 6 is 4, okay? Now I'm going to do another one for row 3. What do I need to multiply? So I'm going to do -3 times row 3. -3 times row 1 plus row 3, and that'll be my new row 3, okay? So that would be 0. That would be -3 times 1 would be -3 plus 3 is 0. -3 times 1, so I'm here now. -3 times 1 would be -3 plus 4 would be +1. I'm over here now. -3 times 1 would be -3 minus 1 would be -4. And then that would be -3, and this would become 10. So I now have zeros. Notice I have my zeros below my first one. So that's what it takes to be in the beginning of row echelon form. But then it says, so let me see here. And by the way, this is one from your book. I just wanted to do one that you guys could refer back to. Now we got to go again because I then want, let me see. We then want the next one, the next leading one to kind of be like a staircase. So I'm going to interchange. So this will be 1, 1, 1. Notice there's a lot of rewriting. I'm not really messing with row 1 right now. Now I'm going to interchange row 2 and 3. So I'm going to interchange row 2 with row 3. So this will now become 0, 1, -4, 4. Oops, sorry, 10, -4, 10. And then this will become 0, 0, -2, 4. Okay. Now we got to go again. Oops, that's a little high up. So we're going to go again. And now we have, so we have a 1 here with zeros below. So we're okay. That's not too bad. But now we need this guy to be a 1, okay? So now what I'm going to do is I'm going to rewrite 1, 1, 1, 1, and then 0, 1, -4, 10. And now I'm going to do -1/2 row 3 equals or yields a new, I guess I could say equals a new row 3. Now notice I didn't add anything or subtract anything to row 3, I just multiplied. That's this rule right here. Rule 2 of replace a row by a non-zero multiple of that row. So rule 2 right here is what I'm using. So I come back here and I'm going to multiply row 3. Oops. I'm going to multiply row 3 by -1/2. So that would be 0, that'd be 0, that'd be 1, and that would be -2. Okay. Now, the way that this helps us solve is I now know, remember, this is my X column, this is my Y column, and this is my Z column, and this is my equal sign, right? So I have all of that. Okay. So what I'm going to do is I'm going to go and I'm going to solve. I'm going to take this row and I'm going to write what it means. Well, I have 0 x's, I have 0 y's, but I have 1 z. So I'm going to say 1 z is equal to -2. Okay. Now I'm going to write the next row. The next row says 1y minus 4 z's is equal to 10. Okay. And then I'm going to write the next row. Well, you know what? Let's solve this. Y equals y minus 4 times -2 equals 10. So then y equals y plus 8 equals 10. So y equals 2. So we found y and we already know z. Now it says that x, the very first row, x plus y plus z, why do I keep writing wrong? Z equals 1. And now I plug in everything I know. X plus 2 minus 2 because of z is equal to 1. So this would be x equals 1. So I now found x. So here's my solution. 1, comma 2, comma -2. So this is how we can use row echelon form to solve a system of equations for us. So what I'd like to do now, you guys, is I'd like to show you how to do the same exact problem, but in our calculators. Okay, so please get out your calculator. Pause the video if you need a minute to go grab it. I'm just going to rewrite the exact same problem in matrix form. So we have, you know, so I could say like solve using calculator on exam or something like that, right? So you would get this system, 2x plus 2y equals 6. You'd get x plus y plus z equals 1. And then you'd get 3x plus 4y minus z equals 13. So it's the same system. And now I'm going to put it in matrix form. So on the exam, I would ask you to write it as a matrix to show me that you know how to do it, which is pretty straightforward and easy, right? So you get 6, and you get 1, 1, 1, 1. And then you get 3, 4, -1, 13. And then what I want you guys to find on your calculator is I want to do let's do REF first. You know what? I want to do RREF. You guys could do REF because I just showed you that by hand. Let's go really fancy. So the difference between REF and reduced row echelon form is you see here how I have zeros in this little like triangle, right? Well, the difference between reduced row echelon form and row echelon form is reduced row echelon form also has zeros here, here, and here. So you get this triangle right here is also zeros on top of this triangle being zeros. And that makes it really nice and clean to solve. So if you can put things in reduced row echelon form, it's always, or not always, but it's usually better because it's so quick to solve. So all we have to do is we take this matrix. Now I already have my calculator brought up. So here's what I want you guys to do. You go to second function, and then right here on the x to the -1, it says matrix. And I'm going to go over to edit my matrix. So I'm going to edit matrix A. I hit enter. And this is what size matrix? This is a 3 by 4 matrix, right? So now you just enter in the values that we use. So we had 2, 2, 0, 6, oops. And then we have 1. One's all across the boards right there. And then 3, 4, -1, 13. 3, 4, -1, and 13. By the way, you guys, make sure that you use this negative right here. This negative is very important, okay? Do not use the minus sign right here. They're two different things. So please do not do that. Okay, so we have our matrix set up. So then I think everything's right. So now let's go second, quit, okay? Now you go back in and you go second matrix and you go over to math. And then you go all the way down until you see RREF right there. On my calculator, it's letter B. So I'm gonna hit enter. And now what it's doing is it's asking you, what matrix do you want me to RREF? So what I'm gonna do is I'm gonna go back into matrices, second matrix, and I want my matrix A under names, and I hit enter. So then I hit enter again, and there is my matrix, 1, 0, 0, 1, So let me write that down. So here is, you know what, let's do this. So this matrix is 1, 0, 0, 1, 0, 1, 0. It should be 2. And then this one should be 0, 0, 1, negative 2. Let's double check. So 1, 2, negative 2. So 1, 2, negative 2. Perfect. Okay. So now the reason this is so nice is look at, if we look at row 1 says that 1x is equal to 1. If we look at row 2, it says that 1y is equal to 2. And if we look at row 3, it says 1z is equal to negative 2. So what we did is we were able to solve the system of equations very quickly. Look at this versus what we had to do up here. Much different. So what you're doing up here is you are showing that you know how to solve a matrix by hand. Oops. And this is kind of the old-fashioned way. If any of you go on to take linear algebra, you will be doing a lot on your calculator, but at first they will make you use your integration, or linear algebra by hand. You'll have to solve matrices by hand. So you do have to know how to do RREF and reduced row echelon form, okay? So let's look at another one. Okay, so let's look at this one. So I want to solve the system. So again, guys, you remember this is an exam on matrices. So when you take this exam, you have to use matrices. You can't use like the old way that you used to solve systems of equations. You have to use matrices, okay? So solve the system using matrices. Okay, so we have 6x matrices and row echelon form. Maybe that's a better way to say it. 6x. You know what? Is there an easier one? This one looks really tough. Let me find an easier problem for you guys. Yeah, that one's kind of rough. Doesn't look like I have a better one. Yeah, I guess I'm gonna have to do that one. I don't have a better one handy. Okay. So we have 6x minus y minus z equals 4. And we have negative 12x plus 2y plus 2z equals negative 8. And we have 5x plus y minus z equals 3. So we have the system. So the very first thing you need to do is put it and show me that you know how to write it as a matrix. And then negative 12, 2, 2, negative 8, 5, 1, negative 1, 3. So we have our matrix, right? 4, negative 8, 3, 4, negative 8, 3, negative 1, 2, 1. You should always double check too, because there's a bunch of times that I've made silly mistakes and I can't understand why I got the matrix wrong. So what I'm gonna do right now is I'm gonna see if I can use my calculator, okay? So let's see if we can use our calculator to just put it in RRE or in REF. So I'm gonna go second matrix, and I'm gonna go to edit. So we gotta enter this new matrix in. Okay, so this new matrix is still 3 by 4, but it's now 6, negative 1, negative 1, 4, negative 12, 2, 2, negative 8, and then 5, 1, 1, oops, that's a negative 1, and then 3. So hopefully I entered it in right. Let me see, 6, negative 1, 4, negative 12, 2, 2, negative 8, 5, 1, negative 1, 3. Okay, so what I'm going to do now is I'm going to quit. I'm going to get out of there, and I'm going to go second matrix. I'm going to go math, and I'm going to go down to REF. Okay, and then we're going to do second matrix A and hit enter. Now you see how it's ugly decimals? All you have to do is go into math and then fraction and hit enter, and it will give us the fractional answers to this. So let's go to right there. So now if you notice on my screen, I have a bottom row of zeros. Remember, in row echelon form, they said that the bottom row, if you have a row of zeros, you have to put it in the bottom. So they did their job. So let's go over to here. So let's go row echelon form. And again, you're just telling me what you did. So this would be 1. I believe it is negative 2, 0, 1, 0, 1, negative 1 over 11, negative 2 over 11, 0, 0, 0, 0. Let's just double check. So 0, negative, so 1, negative 2, 0, 1, 1, oof. Oh, okay. They did it a little bit more fancy than we did. I think that's still right though. Let's see if it works. So let's go with that. So if you did it by hand, you wouldn't get that exact setup. You would get it slightly different because I think they interchanged 2 rows in a different spot. But what this means then is that, let's do the first row. X minus 2y equals 1. And the other row is y minus 1/11 z equals negative 2 over 11. Okay, so far so good. Oops. Oh, I'm doing one different front. So this is 1, negative 1/6, negative 1/6. Let me double check and make sure that I entered this in correctly. Let's see here. Second matrix. Oops, clear. Second matrix. And let's go to edit. So I did 6, negative 1. Let me double check this. 6, negative 1, negative 1, 4, negative 12, 2, 2, negative 8, 5, 1, negative 1, 3. Well, yeah, it's correct. It just looks like the calculator. If you do it by the calculator, it's slightly different than if you did it by hand. So the one that I have here is if I did it by hand, and I just wanted to show you something like this. So this is if you did it by hand. I already have this worked out from your book. So I'm just going to go with this, but it should work with the calculator too. I'll come back to it when I'm not videotaping and we'll go over it. So the thing is we have x minus 2y equals 1 and y minus 1/11 z equals negative 2/11. Whenever you get a bottom row of zeros, one of 2 things happen. You either have infinite solutions, which means it's a dependent system, or you have no solutions. Now, in order for this to be no solutions, it would have needed the bottom row to look like this. It would have needed, who cares what's here? The bottom row would have been 0, 0, 0, and then you would have had your little bar, and then you would have had like 3. Well, 0 cannot equal 3, so that would have been an inconsistent system. Right? That would have been inconsistent. But because we got 0 equals to 0, that means that it is a consistent system. So this is consistent. Consistent. I think it's with an A. Consistent. However, it is a dependent system. And when you run into a dependent system, you're basically saying that one of the variables is builds the other variable. So we're going to basically solve everything in terms of z. Okay, you normally, the variable that got eliminated, that becomes the parameter. Okay, so now we're going to say that x is equal to negative 2y plus 1. So I just moved, oops, plus 2y, sorry about that. I added the 2y over to the other side. And here I'm going to say y is worth negative, oops, plus, why do I keep doing that? 1/11th z minus 2 over 11. So we're saying that if you tell me z, I can find y, okay? But I also want x written in terms of that. So here I have x equals 2 times y, but we just said that y is worth 1/11th z minus 2 over 11 plus 1. So x is actually worth 2z, oops, 2/11th z minus 4 over 11 plus 1, which is actually 2 over 11z. That would be what, 22 minus 4 would be plus 17 over 11? Is it 17? Oh no, why did I do 22? I only needed 1/11. So it would be 11 over 11 minus 4 would be 7 over 11. There we go. So we now know that x is worth 2 over 11 z's plus 7 over 11, and y is worth 1 over 11 z minus 2 over 11. So the way sometimes they ask you to write this is what they might say the solution set is, okay? So they may ask you to write it like this, x comma y comma z, such that, and then they'll say x is worth 2 over 11z plus 7 over 11, comma, y is worth 1 over 11z minus 2 over 11. Oops. And z equals any real. So that is oftentimes how you have to write a dependent system. Okay. And then if you get a situation where you put in REF and you get 0 equals a number, like 0 equals 5, so the x cancels, the y cancels, and the z cancels, or the x and the y, you know, whatever the size of the matrix is, and you get 0 equals a number, then you say it's inconsistent, there is no solution, and you're just done from there, okay? So inconsistent systems are actually pretty nice. I think that's going to be it for this, guys. Please try to use your calculator. I'm going to have to maybe talk to you guys in the meeting, or we'll go over this one together. Why doing it by hand is giving me a slightly different value than the calculator. The calculator must go one step further when it does its REF. So I'll have to look at that. But that's going to do it for this video, guys. Hope this helps with the new homework.